Okay, let's talk about serverless. It's a huge buzzword, but what does it actually mean? We're going to get past the hype and look at how it really works.
This question right here is the core promise of serverless. It's not about a world with no servers. That's impossible. It's about a world where you don't have to think about them. And to see why that's such a game changer, we got to look at how we used to do things.
Right, so before we can really appreciate this new model, we have to understand the pain of the old one. Let's take a look at the classic way of running applications and see why everyone was so ready for a change.
For the longest time, the virtual machine, or VM, was king. But VMs have some built-in problems. The biggest one? Wasted money. You had to guess how much capacity you needed, provision a server, and then pay for it 24/7, even if it was just sitting there doing nothing half the time. Plus, scaling up was slow, and you are on the hook for every single OS patch and security update. It's just a lot of overhead.
Serverless just completely flips this on its head. Instead of paying for a server to be on, you only pay for the exact moments your code is actually running. We're talking down to the millisecond. All that management work, the patching, the updates, gone. And scaling? It just happens, automatically. This is a totally fundamental shift in how we buy and use compute power.
So yeah, all those headaches with traditional servers really pushed the industry to find a better way. And what came out of it was a whole new level of abstraction, a different way to even think about building software.
The core idea here is pretty simple when you break it down. A serverless app does one of two things. It either hands off work to a third-party service, or it runs its own code in these things called ephemeral containers. Think of them as temporary environments that pop into existence to do one job and then just disappear. The whole idea of an always-on server just isn't part of the equation anymore.
And this quote from Werner Vogels, the CTO of Amazon, just nails it. Of course, servers still exist somewhere. The whole point is, they're not your problem anymore. The cloud provider deals with all of that, which frees you up to just focus on what your application is actually supposed to do.
So let's break down those two pillars. First, you've got BaaS, or Backend as a Service. This is all about using managed services for common stuff you need. You know, databases, user authentication, file storage. Instead of building it yourself, you just plug into a service that does it for you. And then there's FaaS, Function as a Service. This is where you run your own code, but as these little isolated functions that get triggered by specific events.
Now, this whole FaaS thing really exploded back in 2014 when AWS launched Lambda. It was the first time this abstract idea became a real tool developers could use. Then, a year later, they added API Gateway, which was the missing piece that let you connect these functions to HTTP requests. And boom, the serverless API was born. Now, every single major cloud has its own FaaS platform.
Okay, so we've talked about the big idea behind Function as a Service. Now let's get our hands dirty and see what it actually looks like when you sit down to write some code.
At its core, this is it. This single function is your application. In the old world, you need a web server, a router, and a whole bunch of other code just to get started. Here, you just write the logic. That event thing has all the data that kicked off the function, like the body of an API request or info about a new file. You do your work, you return a result, and that's it. It is radically simpler.
And the whole process is incredibly simple. You write your function, you upload the code, and then you tell the platform, hey, run this code whenever this happens. When that event occurs, the platform instantly spins up a container, runs your code, and then tears it all down. And the best part? You only get billed for those few milliseconds it was actually doing something.
And what kind of events can trigger these functions? Well, pretty much anything you can imagine. An HTTP request is the obvious one for building an API, but it could also be a new photo being uploaded, a message popping into a queue, a record changing in your database, or even just a simple timer that runs a task every hour. The flexibility here is just huge.
So that's the theory. But where does the rubber actually meet the road? Let's look at some real-world examples where serverless just makes perfect sense.
If you look at what people are building, it's clear that building APIs and processing data are the big winners. For example, think about resizing an image. Every time a user uploads a photo, a serverless function can instantly fire off and create all the different thumbnail sizes you need. Or imagine processing a flood of data coming from thousands of little IoT sensors. These kinds of quick, event-driven jobs are the perfect fit.
And here is a fantastic example of how you can string these services together to build something really powerful. This is a recommendations app. A user request comes in through an API gateway, which then triggers different Lambda functions. Those functions talk to a database like DynamoDB, a search service, and even a machine learning model to get predictions.
You end up with this really sophisticated system, and there's not a single server that the developer has to patch, manage, or scale.
Okay, let's switch gears and talk about the money. Because honestly, while the tech is cool, the economic model is what really makes serverless so disruptive. This is the heart of the value proposition. You're not renting a server by the hour anymore. You are buying tiny, precise slices of computing time. If your API gets zero traffic all night, your compute bill for that time is zero. You just can't do that with a traditional server that's always on.
The pricing model is incredibly granular. If you look at this example from Google Cloud, you're paying a tiny fraction of a cent for each time the function runs, plus a fee for the compute time it uses. And they measure that time in what they call gigabyte seconds, basically a mix of how much memory you used and for how long. It's a total move away from paying for capacity to paying purely for consumption.
But here's the catch, and this is important. Serverless is not always the cheapest option. It's a trade-off. For any job that's bursty or has long periods of inactivity, serverless is almost always the winner. Your cost scales right down to zero. But if you have something that's getting hammered with constant, heavy traffic, a good old-fashioned VM that you pay for 24/7 might actually be cheaper in the long run. It's all about using the right tool for the job.
So if you remember one thing from all this, it should be this. Serverless doesn't mean the servers are gone. They are very much still there, spinning away in a data center somewhere. What's gone is your responsibility for them. The server just becomes an implementation detail that you, as the developer, don't have to worry about anymore.
So ultimately, that's the real question to think about. Is serverless the end of servers as we know them? Or is it just a much, much smarter way to rent them? It's a powerful new layer of abstraction, and understanding when and how to use it, well, that's the key.